Hello, Mr. Chu here with Bear Algebra, and I'm wearing a tie. I'm wearing a smiley tie. I have a smiley face here with some Disney characters on it. I have lots of ties. I'd wear a different tie every day when I was teaching in brick and mortar. And the students knew that I was going to wear a different tie. And Bear is saying this lesson's hard, but don't get choked up over it. So we're going to solve systems of equations using elimination and multiplication. So if you recall in an earlier video when we were working these types of problems, we added down and a variable went away. So if I add down, I get 8x plus 4y equals 8. I've still got an x and a y. It didn't help me out. If I subtract, I would get 6x plus 6y equals 24. Didn't help me either. So anytime you have a situation like that, there Bear is telling you not to get all choked up again. He's a choker sometimes. I have to take and multiply either the first or second one or both and then add down. So in this case, I can either multiply that second one by -7 and add down and the x goes away, or multiply by 5 and then add down and the y goes away. It's easier to multiply by 5 because it just automatically goes away. So whenever I'm solving these, I always put a line and I rewrite an equation if I don't do anything to it. Well, I'm not doing anything to the top one, so I rewrite it. That second one, though, I'm going to multiply by 5. So I take a 5, put it in parentheses out in front of the x minus y in parentheses. Then I write my -8 here, but if I multiply the left by 5, I have to multiply the right by 5 using the multiplication property of equality. All right, so here we go. I put another line. I rewrite the top one because I haven't done anything to it yet, and it's in good shape. But I have to do the distributive property. 5 times x is 5x. 5 times -y is -5y. And then -8 times 5 is -40. All right. Now when you add down, look what happens. The y's are gone. 7x plus 5x is 12x. Plus 0, so that's 12x plus 0 is 12x. 16 minus 40 is -24. Now I'm going to solve for x, so I divide by 12 on both sides using the division property of equality. 12 over 12 is 1, 1 times x is x, so x equals 2. So now that I've got 2, I can take and substitute that back in to either equation and then find y. So x equals 2, and I take 7 times 2 using my top equation plus 5y equals 16, and now I solve this. So this is 14 plus 5y equals 16. This is not 2. See, I knew that I made a mistake here. I'm just going to keep going to show you how I knew I made a mistake. So I have 5y equals 2, y equals 2/5. I know it's not going to be 2/5, which means I made a mistake. So that's why we always check them. Now let's go back and let's see where the mistake was. -24 divided by 12 is -2. You can't mess your negative signs up because it does make a difference. So this is -14 now, plus 5y equals 16. That's why checks are important. I'm going to add 14 to both sides. -14 plus 14 is 0. 0 plus 5y is 5y. And that equals 30. Now I'm going to take and divide both sides by 5. So y equals 6. So I believe my solution is -2, 6. So I think that -2, 6 is the solution. I'm just going to write it up here. That would be the point at which both of these graphs intersect. So what do I do now? Now I'm going to check it. So in my very first equation, my 7x plus 5y equals 16. I can check that now. So let's take my 7 times my -2 plus 5 times 6. Does that equal 16? So 14 plus, it's -14, 30. Does that equal 16? 16 equals 16. Check. Okay? Next, I check the second one. So I'm checking x minus y equals -8. And I put my -2 minus 6. Does that equal -8? -8 equals -8. 2 checks. It did check. Okay, so this one is harder now. Why is it harder? Because I don't have just one. If I just multiply a top one by a number or the bottom one by a number, nothing goes away. I've got to multiply them both. There's 4 ways you can do it. I'm just going to show you one of the ways. I'm going to take the smaller, the 2 and the 3y, and get rid of the y by multiplying the top by 2 and the bottom, no, it's the top by 3, and the bottom by -2. And I'll show you why I did that. So now when I do my 3 times my 2y, I got 6y, and my -2 times my 3y is -6y, and it goes away. So the easiest way to do that is when you can't just multiply by one equation and get it to eliminate, then you're going to do 2, and I usually do the 2 smallest variables. It just seems to make more sense. So now I do the distributive property. 3 times 7y is 21, or 3 times 7x is 21x. 3 times 2y is 6y. -3 times 3 is 9. Now -2 times 8x is -16x. -2 times 3y is -6y. And -7 times -2 is +14. Now, I add down. 21x minus 16x is 5x. Plus 0 is 5x, because that cancels out, which is what I wanted. And that equals, now again, I made a quick error here. -3 times 3 is -9. And I knew that because it didn't work out. So -9 plus 14 is 5. So you have to be very careful. Use a calculator if you need to. If it helps, use it. So 5x divided by 5 equals 5 divided by 5. And the 5 over 5 is 1 times the x is x. 5 divided by 5 is 1. So I believe that x is 1. So if x is 1, I can solve for y now. And I can take either equation. It doesn't matter which one. Let's take the top one. I substitute using the substitution property of equality. I have 7 plus 2y equals -3. I subtract the 7 from the left and from the right. And the 7 minus 7 cancels out using the subtraction property of equality. 0 plus 2y is 2y. -3 minus 7 is -10. You could hear Brack barking outside. So now I have 2y, divide it by 2 using the division property of equality. 2 over 2 is 1, 1 times y is y, negative 5. So I believe my solution is 1, negative 5. So I believe the solution is 1, negative 5. And remember, here's my x, here's my y. Sub them in to both equations to see what happens. So we'll substitute it into the top one. So I have 7 times 1, because I got an x here, plus 2 times negative 5. I'm going to need more room. See, I'm getting ready to hit that pen over there, and I don't want to do that. So I have 7, x is 1, 2 times y is negative 5. I put a little question mark above the equal sign, negative 3. And if it solves, that means that this point is on the graph of that line. Then if it solves here too, since it's on both of them, it's the intersection point. 7 plus negative 10. Does that equal negative 3? It sure does. So I know that that one is on it. All right, so now what do? Now I'm going to check the bottom one. So 8 times x, and x is 1, plus 3 times y, and it's negative 5. And we're saying that equals negative 7. So 8 plus negative 15, does that equal negative 7? Negative 7 equals negative 7, it sure does. There's 2, which means it is the solution. So if I graph this line and graph this line on the same grid, it will intersect in the point 1, negative 5. So make sure you subscribe down here so that you can see more of these videos. And right now I'm going to erase part of this and put up your challenge problems. You can write these down on a piece of paper just to see how well you understand. And then you can pause this video, work on them out. After you work them out, solve the system of equations using elimination and multiplication. Challenge 1, 2x plus 3y equals negative 5, and 5x plus 6y equals negative 8. Challenge 2, 4x plus 3y equals 1, and 2x plus 5y equals 11. Pause this video. There'll be a link up here you'll be able to click on once you turn it back on after you've worked them to see if you did them right. A link down here with other algebra elimination videos. I'm Mr. Chu. This is Bear Algebra. Subscribe, like this video so that I can spread out and give my videos help to more people. Remember, Mr. Chu wants to help you with algebra.